Hello. In this video, I am going to provide you an example of how you might go about developing a revenue projection for the business opportunity analysis. Since we are going to be employing a method it's called the percent of sales or percent of revenue method, this is sort of an ideal way of getting started is by just developing the revenue piece. Now, I'm going to use a particular approach to this. I refer to it as a dynamic model, and that approach basically means that we keep to a minimum the number of hard-coded values that we're going to use, and we use formulas in as many places as we can. The advantage of that, a couple of things. One is you may get through the entire business analysis process and decide you're either too conservative, too aggressive on some of your revenue assumptions, but it also allows you to more easily do some stress testing throughout the model. And so this is the cutting edge, sort of the state of the art, if you will, right now in developing business forecasts. So I wanted to make sure that you guys had seen this. So we're going to start out first by creating a few roadmaps. Remember that when you're building a business model, you're building it for somebody else, not just for yourself. So it's important that you make sure that they can understand everything. So the first thing we're going to do is put across the top what period we're in. I'm going to use M for months, Y for years. We're going to go month 0 first. Now I leave this blank column B because sometimes in a dynamic model there's some variable that you want to keep and use in all your formulas, and in this case I leave that for those variables. As far as month 0, this M0, I use M0 to indicate the period of time during which you're making the initial investment. So a lot of times you have to put up some money first and then the project starts. And so generally speaking, that is in valuation and in science, finance, that's considered time period 0. In this case, we're just going to call it M0 for month 0. I also like to kind of pretty things up a little bit. You'll find that about me throughout the process. And I just do that as I go. Now, a little Excel trick. You see the little kind of box at the bottom there? If I move my mouse over it, it turns into the plus sign. If I do that and drag to the right, you'll see that it is dragging it out, and because the far right value is a digit, it's incrementing it, so I don't have to do anything for that. So I've now created months 0 through 12 in my labels. So that's all of year 1. Now I'm going to go year 2. And you'll see that because I put it adjacent to that, it's sort of similarly formatted, but not exactly. And go through the same process and drag that out. Now I'm going to year 10. Some of your projects you only need to go to year 5, but year 10 is kind of a standard for these kinds of forecasts, so I like doing that. And then we're going to create a revenue driver section, which will result in the forecast. I call these drivers, I call this section drivers, primarily because in a lot of cases, they are variables that help us to calculate what the revenues will be. So you could call them factors or whatever else. Now remember, for my business opportunity, I am assuming a restaurant near campus, maybe adjacent to campus, certainly within walking distance of campus. And I am assuming that they are going to primarily have as customers either students that are on campus or near campus, faculty and staff that are working on campus, and then maybe some of the surrounding communities. So we're going to kind of build up each of those. So, number of students on campus per day. And we're just going to start out by basically going out and go to year 2, and we will say that there are about 1,000 on campus. we can talk through why that's a reasonable assumption at some point if you want to. It's what I'm going with, and it's a hard-coded value, so I'm going to highlight that one in yellow. Okay, and I'm not really projecting that the amount of students on campus is going to change that much. So we'll go ahead and just make all these equal to it. So equals whatever P4 is with a dollar sign in front of it. That keeps it so that when I drag this formula, that's still P4. If I hadn't done this, this would then be Q4, and that's not good for us. It's a blank. So we're going to do that. Then I can actually take this, copy it over here. And so you'll see P4 all the way throughout. And so now we've got a situation where all I have to do is change this. Let's say I say, oh, I was wrong, maybe it's 1100. Everything changes to 1100. So next thing that we have is the percent of student customers per day. So what percentage of them are going to eat at our restaurant per day? This one's a little bit trickier. Let's go talk out here in year 2. I'm going to say maybe 20%. That sounds high, but remember that this place is going to be open for 3 meals a day. Some people might eat at it twice in a day. And so you're really talking about out of the entire day of those 1,000 students, 200 students, or think of it as maybe 60 students a meal. That's not a wholly unrealistic thing. Plus, remember that we do have students that live on campus, and so a certain number of those will maybe, either do their lunch or their dinner there, and that might be higher. So we're going to go with that. Now, challenge with this one is that, quite frankly, we aren't going to start out on month 1 having that many people, because we need a little bit of time after we spend our money to actually get the place open. So we're going to assume that it's not going to open. I'll go ahead and highlight up here these 2 periods, because those are the ones we're working with. But it's not going to open until month 3. And in month 3, it's only going to have, call it 1% of the student body. So kind of a grand opening, however you want to think about that. And again, we may change that assumption, but it's, we're just going to leave it blank before that. That's going to count as though it's a 0, so that's fine. Now, I want this to then grow from 1% to 20% over the time. And I really would like it to be at 20%, say, by the end of year 1. So we'll just make that one equal. And then what we've got, 1, 2, 3, 4, 5, 6, 7, 8 steps in between. So I'm just going to say, so it's going to grow. This basically has it grow as a straight line. So equals this amount minus this amount. I got to put dollar signs in front of those so that those columns don't shift when I copy the formulas. Okay, so I got those 2 amounts. It's going to go in 8 steps, so each step is 1/8 of that. And to it, I'm going to add whatever the prior day was. Okay, so you'll see what that's doing. And we'll go up here and just sort of reformat so everything fits. And you'll see 3, 6, 8, 11. I think if we expand this out just a little bit, you'll see a little bit smoother pattern. But basically, that gets us this sort of smooth growth rate up to 20%. It actually gets to 20% in month 11. So I'm going to change this a little bit. Let's get rid of that. Let's tie all of these to column P. Okay. And let's make it 9 steps, because we now go 9 times over. And we'll just do that. And so you'll see that it gets here by month 12, which is what we wanted before. And I don't have that formula that way. And after that, we're just going to assume that it sort of flattens out. Okay. And so what does that mean in terms of students per day? equals that times that. So, yep, 0 students. That all makes sense. Get up to about 200. You'll see it's got these partial students. I don't love that, so we're going to go ahead and put a round in there. We're going to round it to the nearest whole number, so that's a 0. And that way we're not dealing in partial people. Sort of confuses things, so I like that. The other thing is that when I do these and I get to something that's a meaningful sort of result, and in our case we're trying to get to total customers first, I like to put a little bit of highlighting around it just so that I can go back and look and say, oh yeah, that's that. We're now going to do the same thing for faculty. I'll change these to faculty. We'll call it staff, faculty, staff. So there we go. Need to make that a little bit wider. Okay. And because of the approach is basically the same, it's just a different number of people, I can just take the entire formula that I used before, the entire structure for students, and use it again. So I'm just going to copy paste. There aren't 1,000 faculty. There are really only 300 faculty and staff. So we'll drop that down. I still like the 1%. And the 20%, so all of that holds. Again, if you want to make different assumptions, you could. You could say, oh, this is 25%. You could say, you know, maybe they're the early adopters and they start out at 5%, however you want to do that. So you can make those kinds of changes if you want. I'll just leave it at that for now. So then we've got another category, which is, call it other customers. And the challenge here, for me at least, is I don't really know. I don't have a sense of what that might be. You know, if I had demographic information and so forth, I might build it out sort of the same way. But I'm just going to go with something simple for now, show you a different way of doing things. Let's just say that we reckon there's going to be about 40% of those steady state. Is what I would call it. And so that's a hard-coded number. We'll go ahead and highlight that. And we'll say that everything after it, call it 40. We could put some growth rate in there if we wanted to, but I'm not gonna for now. So we'll go 40. Okay. And we're going to assume that, again, we don't open till here, but when we open, we're not going to get any. All right, and so because we're not going to get any, we've got to somehow build up to 40. I can use the exact same formulas I used before to build up to it. I'm just copying and pasting them. And then gotcha here is, again, I got to put the round around it. So that I get a, don't know what I did there. Let's see, round. Oh, I'm short of parentheses, sorry. So that I don't get partial students. And there you go. Kind of gets me where I need to go. I've got to highlight that because it's not a formula. And we've got other customers. Highlight those guys. They are certainly one of my inputs. And so now we could just go down and say, what are my total customers per day? And that's an important number. So a lot of times I move those over and offset them a little bit differently. And again, since it's a total, we're going to take that. I take a little bit darker shading on that just so it stands out a little bit. And it's simply equal to this amount plus this, so the faculty plus the other. And of course, there's none in the beginning. There's none for the first couple of months. But when you drag the thing out, you're now looking at growing to about 315 customers a day. Not a bad result, quite frankly. So that gets us the customers, but now we've got to figure out what each one's going to pay. So we start out with the average dollars, let's call it, per customer. And I'm going to go ahead and we're going to take a slightly different approach here. We're going to say the real dollars, real being today dollars, in our case, let's just say. And we're going to go ahead and set those at $10 a customer. And that's a hard-coded number, so we're going to put that in yellow. Do we do that? Yeah, there we go. And I'm going to just set that equal to it. Now I'm doing something different here, which is I'm just going to drag this formula without the dollar sign. So it's just saying it'll be whatever it was last time. Okay. I'm not necessarily using that right now, but the benefit of it when you do it that way is, let's say I go into, year 2 and say, oh, I'm going to move them up to $12. Well, now everything after that has changed, so that's useful. But for now, we're not going to take advantage of that right there, but I just want to show it to you. Now, so the idea there is in today's dollars, they're going to spend $10, but inflation's going to happen. Remember, inflation is sort of this notion that things are always getting a little bit more expensive. So we got an inflation rate. All right. And right now, we're just going to say that it's 0. And it's usually stated in a %. Okay, and we're going to drag that through. Again, same sort of thing it's reading off. So I'm going to highlight that. Except for that in year 2, I'm going to say that goes up to 2% a year. Did it wrong, didn't I? So it equals that. Can't just drag 0. I got to actually drag a formula. My bad. So we'll do that. In year 2, we'll say it's 2%. And you'll see that makes every year after that go up at 2%. Okay. So then we get to calculate an inflation factor. And the inflation factor is, in the first instance, it's just 100%. Okay. It's 100% because we're saying the prices will be what they will be. And then the factor will be, that is equal to 100% times 1 plus whatever the inflation rate for the period is. And so, lo and behold, that's 1% as well. So I'm going to hard code that. Actually, I'm not, because I'm not going to highlight it. Yeah, I am. Sorry. And we drag that formula out, and you'll see it just keeps being 100, 100. Now it's 102, 104, 106, 108. So it's growing. And so the idea is that this factor is a number that you can in any year you can calculate by today's dollars. Think of it like a consumer price index. You calculate today dollars times that, and they'll tell you how many dollars it is at that point in time. And I can't spell inflation apparently. Fix that. All right, and so now I can do average dollars per customer, what we would call nominal. All right, so it's nominal because we've adjusted for inflation, so it's simply equal to the real rate times the inflation factor. And there you go. And you'll see we wind up at about $11.95. So things do actually grow a little bit over time. So if we pause for a second, we think, oh, well, we've got the customers per day. We've got the price per customer. We'll highlight that. Again, I'm going to shift that over because that's an important input for me. And now what we need are days open. Okay, and I'm going to work off of the assumption that we're on a 20-day a month sort of thing. I mean, technically, it doesn't matter that we aren't really open that many days there. So maybe we should do that in period 3 instead. Get rid of that. And let's just reverse all of that. There we go. Put it in on month 3. There we go. And again, we're just going to use the formula that extends that out so that we can change it whenever we want to. And here what we've got to do is say, well, it's 20 a month, but it's no longer monthly, it's annual, so it's 240. Okay, now that's one way of doing it. The other way we could do it instead of hard coding it is just say it's equal to whatever this is times 12. Now it's formula driven again, and we don't need to do anything else about it. All right. So again, highlight that. You'll see I'm a little bit of a stickler for the highlighting. Again, most important thing for you to remember as you go through this process is you are not building this model just for yourself, you're building it for others. All right, so based on that, I now have an estimated revenue. Okay, and so estimated revenue is quite simply, it's equal to the number of customers per day times the amount they're going to spend per day times the number of days in the period. Okay, and that's all formula driven all the way out. So let's see where we wind up. I'm going to go ahead and round those just simply because, or shrink the formatting, I guess, not really round them, but simply so that this fits better. And I don't know if you guys know this little trick, but if you click this upper left box, it highlights the whole sheet, and then if you double click, it kind of puts everything together. I'm going to shrink this down a hair so that we can see everything. But you see out here with our assumptions, that's put us at about $903,000 a year. So, I mean, it's a real business at that point. It's not, wow, what a nice little quaint place next to the college. I mean, it's real money. So I'm going to go ahead and hit that. So at this point, I have built a dynamic model of my revenue. Again, I could go in, for example, and say, oh, I was off. Let's just make this 1,100. And you'll see that everything changes, and that bumps me up to 960,000. Take that back. I could go in and say, you know, I actually think that we're going to get 25% of the students a day. And again, see where that winds me up. We're looking at over $1 million a year then. I might drop that down. And I might say, you know, actually, even though it's still only, say, 20%, 200 students, I'm going to say that we're going to go for 6 days. And my logic on that is that, oh, and I forgot to highlight that. There we go. My logic on that is that we're going to also be open on Saturdays and Sundays, or on Saturdays, and there are students on campus and nothing else is open. So they very well might eat that. So, you know, if it's 6 days, then that's 24 days in a month. And we do it that way, and you can see how things bump up. So anyway, you can see that a key element to this, of course, we could also say, well, maybe they're going to spend more like $12 a day and, you know, see what happens with that. Why did that not? Not exactly sure what happened there. It's also a great way to sort of check that everything's working the way you think it should formula-wise as you start changing these numbers, and you know you want to make sure that you get the result you think you're going to get. So things change the way you want them to, all of that. We might say that inflation is going to be 3%. And you see that changes things. So very important to go through and you know sort of make the assumptions, if you will, and test that your dynamics are all working. Anyway, so that's what we got. I'm going to save that. Well, you guys know how to save it. So that's what we got. Hopefully that'll be useful for you. Come to class with questions.